to look at the pH of strong bases, how we can calculate that. It's very similar to the pH of the strong acids, except there's a slight extra step at the end. And also from the start, you're focusing not on the hydrogen ion concentration, but on the OH minus concentration. So here's the first example. So we want to find the pH of 0.15 molar NaOH. And again, this one is easy because they've given us the molarity. So we can go straight on to the step where you're looking at the dissociation. So NaOH breaks down into an Na plus and an OH minus. And if we have a 1:1 ratio between our NaOH and the OH minus ions, that means that if they told us there was 0.15 moles per litre here, then how many moles of OH minus are we going to get? Yes, 0.15 moles. Now we can plug that into our formula for pH, except we're going to have to start with our pOH. And our pOH is our minus log to the base 10 of the OH minus ion concentration, which in this case is minus log to the base 10 of 0.15 moles. And when we plug that into the calculator, we are going to get 0.82. That's our pOH. Now, that little extra step that I mentioned, when you're working with a base, you start from the premise that the pH is equal to 14, take away the pOH. So that adds on one little extra step at the end. In order to get the pH that we were asked for in the question, we have to take our 0.82 away from the 14, and that leaves us with an answer for the pH of 13.18. So that's your first and I suppose easiest example. Let's move on to one that's slightly more difficult again, exactly like we did with the pH of the strong acids. So let's move on to an example of calcium hydroxide. So we want to get the pH again. Oops, not writing for me. We want to get the pH of 0.01 molar calcium hydroxide. Now, the first difference you'll notice is that for calcium hydroxide, when it dissociates, it goes to Ca2 plus and 2 OH minuses. And that being the case, the ratio is 1:2. So if we have a 0.01 molar solution of calcium hydroxide, we will have 0.01 moles of the calcium hydroxide, and that will give us, when it dissociates, 0.02 moles of my OH minus. Now, that 0.02 moles of the OH minus then just needs to be plugged into the formula for the pOH. So pOH is equal to the negative log to the base 10 of the OH minus ion concentration, which in this case means the negative log to the base 10 of 0.02, which works out to be 1.7. Of course, the question isn't over there because we weren't asked for the pOH, we were asked for the pH. So just to remind you that pH then is equal to 14, take away the pOH, which in this case is 14 minus 1.7, and that gives us 12.3 for the pH of your 0.01 molar calcium hydroxide. Now let's move on to one more level of difficulty, and that's where they don't give us the concentration. So they give us a way of calculating the concentration. So what about if they gave us 9 grams of potassium hydroxide? Here, just draw a line under that guy. Oops, not quite under. Stroke eraser, good. So erase it.